Hello, welcome everyone. Today we will discuss about one of the part of organic chemistry. The topic of our discussion is aromatic nitro compound. I am Zamir Sheikh, faculty in the Department of Chemistry, Sri Shivaji College, Akola. I am happy to inform you that our college is re-accredited by NAC with A grade, CGPA of 3.24, awarded CBE status, College with Potential for Excellence, and Lead College status by Sant Gadgi Baba, Amravati University, Amravati. I am Samir Sheikh, Assistant Professor from the Department of Chemistry. The topic of our discussion is aromatic nitro compound. This topic is strictly based on syllabus, particularly from semester 4 BSc second year. So the course objective, or we will discuss the points particularly from that aromatic nitro compounds. First of all, introduction. Secondly, we have nomenclature of nitro compound. Third, we have structure and physical properties. Fourth is the preparation of that aromatic nitro compound. Five is the chemical reactions. What are the chemical reactions particularly for from aromatic nitro compound? Sixth is reduction of nitrobenzene in acidic, in basic, or lastly in neutral medium. These are the chemical reactions. One of the most advanced reactions particularly which is shown by nitro compounds or nitroalkanes is an Henry reaction or Henry aldol. And lastly, the uses of nitro compounds, why we are dealing with the nitro. Okay, so this is the introductory part or objective of this session. So now let's start first part from that your syllabus is the introduction of nitro compound. You know that nitro compound is an important class of an organic compound, that replacement of hydrogen from any hydrocarbon by NO2 group that will give the nitro hydrocarbon. So the nitro compounds are an important class of an organic compounds which may be regarded as derived from hydrocarbons by the just replacement of one or more hydrogen atom by NO2, that is nitro group. Based on the type of hydrocarbon, if we are use the simple alkanes, then resulting compounds are aliphatic nitro compounds. If we use the hydrocarbon as a benzene ring or aromatic skeleton, results in the formation of a nitroarene, or also be called nitro aromatic nitro compound or nitrobenzene. Nitroarenes, that is that compound must have the NO2 group which is attached or which is connected with the aromatic skeleton, that is benzene. So nitroarene is a compound where the NO2 group is directly linked with the benzene ring and have been used as a synthetic reagent since long time. So basically, first know the structure of a nitro group NO2. So that here R is either aliphatic compound, aliphatic alkane, basically what methane, ethane, etc., or it may be as what the benzene ring. So this is the structure of what nitrobenzene, where NO2 is in delocalized form. What is delocalized now? The electrons are shifted from one center toward another center, okay, within a same molecule, that is delocalization. And based on that, so nitrogen form a tetravalent system, but otherwise it is an sp2 hybridized form. So there is a positive charge on the nitrogen while negative charge on the what, oxygen. So basically these are the three, these first two are resonating structures and third is what the its resonance hybrid. So basically first two structures combined together you get the third, okay, that's one. So the negative charge is probably is present only on what the oxygen rather than what the nitrogen. So in general chemistry, in general organic chemistry, we are seeing that resonance. In resonance, the negative charge should be present on only electronegative element. What is electronegative element? The element which have the tendency to withdraw, to share the maximum electron pair. So in this structure, the oxygens are electronegative, so the negative charge should be kept always on the oxygen. Let's move the general features of what nitro compounds. Again, nitro compounds are very important class of nitrogen derivative. So one of the nitrogen derivative. Particularly, nitro group is an oxidized form of nitrogen, while ammonia or amines are the reduced form of what? Nitrogen. The nitro group is just like carboxylate ion, have two resonance hybrid or resonance equivalent structure. I just seen in the last slide. Hybrid structure has full of positive charge on the nitrogen as just previously mentioned, and full of negative charge on what? The oxygen. So in which half of the oxygen share the charge, okay, half on the another oxygen, half on the another oxygen. So basically full on, there are two charges are separated, positive charge completely on nitrogen, while this negative charge half-halfly distributed on the two oxygen. So this is the resonance structure, particularly from the nitro compounds, whether it from the aromatic compound or whether from what? Aliphatic, depending on type of what? Hydrocarbon. Nitro group is quite often represented as containing a double bond between nitrogen oxygen, okay, and one coordinate bond with the other oxygen. So in generally we are represented like this, okay. So but actually the nitro group is stabilized by resonance and is hybrid structures, nothing but the it's contribute two equivalent structure, first two. So this is the general particularly from nitro compounds, and the nitro compounds, I must inform you that, so that nitro group consists of whole three electronegative elements, that is one nitrogen, and other than what? The other are two oxygen, and that's why due to the more number of electronegative atoms are present in that nitro group, it behave the most of electron tendency, or it have the tendency to withdraw the electron from other substituents. For example, if it's attached with carbon, so it will abstract the electron density toward itself, and that's why nitro group is in organic chemistry, nitro group is the best withdrawer. Classifications of nitro compounds. The classification is based on type of carbon attached to that nitro group, whether it is aliphatic or whether it is an aromatic. We can synthesize just by nitration of alkene in vapor phase, treatment of alkyl halide with silver nitrate, you get the aliphatic nitro compound. Oxidation of a tertiary alkyl amines with the potassium permanganate, okay. So these are the three methods particularly from aliphatic, but for topic of discussion is only aromatic nitro compounds, okay. So that nitro group must be linked with, directly linked with the aromatic ring or benzene ring. So what are again we are, yes, nitro, this is nitro compound. Now we will see the synthesis, particularly how this we can compound, how this nitro compounds can be synthesized. So first of all, general introductory part for aromatic nitro compounds. Aromatic nitro compounds are the derivative of aromatic hydrocarbon, that is benzene, naphthalene, etc., in which one or more hydrogen is replaced by what? Nitrogen. Okay. So that results in the formation of what? Aromatic nitro compound or nitroarene. That arene is nothing but the what? The C6H5 derivative or aromatic skeleton. This is the structure of what? Nitrobenzene, okay, where the replacement of one hydrogen from benzene by NO2, and this is a delocalized structure or resonance hybrid particularly from the nitrobenzene. So you must know that, so I am just telling you particularly for nitro group, it is an electron withdrawing group. What is electron withdrawing group? The group that must have maximum number of electronegative elements. All the electronegative elements have the tendency to withdraw the electron, and that group having the what? All the three elements are more electronegative than carbon, that's why it have the ability to withdraw the electron. These are the resonating structures. Now due to the abstraction of electron density toward or outside the ring or toward the nitro group, so the benzene shows the deficiency. That's why, so whenever nitro compounds are there, the benzene nucleus shows the what, less electron density. Okay, so basically it impart the positive character. Why? Because of just the nitro group. And we must see that in nitro compound or nitro aromatic compounds in which the positive charge is only at occurred at ortho or para. So compared to what, three positions, that is ortho, meta and para, two ortho and one para is highly deficient position because it withdraw the electron strongly from that, while meta position is somewhat rich at compared to what, the ortho and para. So this type of what concept is very most important, particularly for chemical reaction, that is an electrophilic substitution reaction on nitro compound. Okay, we will see in next slide, but before that you must know, we must recall that concept. So why the NO2 group withdraw the electron from ortho and para? So here the resonating structures are given. From ortho and para only the electron density get decreased now by just the abstraction of by due to the NO2 group. Preparation, how can be prepared? The nitrobenzene or nitro aromatic nitro compounds are firstly prepared from benzene. So that process is called the nitration, or it is an example of substitution reaction where the benzene on treated with concentrated nitric acid and sulfuric acid. That mixture is called nitrating mixture, will converts to the nitrobenzene. So this type of reaction is an example of substitution reaction where hydrogen of the aromatic skeleton is replaced by incoming NO2 group. Now there are so many different types of substitution reactions are there. Nucleophilic substitution is there, electrophilic substitution is there, radical substitution is there, but in this reaction electrophilic substitution reaction is proceed. So generally benzenes are quite more electron rich and undergo the what substitution. So basically that a nitrating mixture, that is HNO3 and H2SO4 mixed together, will get the nitronium ion, and nitronium ion is an electron deficient species. It will be combined with benzene and results in the formation of what, nitrobenzene. So that whole process is called nitration process. Nitration is an example of aromatic electrophilic substitution reaction, that is an AESR. Another example, if a derivative of hydrocarbons are there, that is an benzene derivative substituent, that is aromatic benzene, it's a methyl benzene, that is toluene. When toluenes are reacted with same nitrating mixture, that is HNO3 and H2SO4, results in the formation of two products. One is ortho, second is para. Orthonitrotoluene or para nitrotoluene. So why these two products are obtained? Because you must know the resonating structures of toluene. Toluene is nothing but methyl benzene. Methyl is electron rich sigma electron donor. It have the sigma electron density. It donate the sigma electron density to benzene. So now the benzene becomes rich. Not like that your nitrobenzene. Nitrobenzene and toluene both have the opposite resonating structures. In toluene, methyl gives the electron density to what, nitrobenzene ring, and due to that reason, so ortho and para positions are what, somewhat rich. So incoming NO2 group will only attached or will only substituted at ortho and para positions, not at the meta. So that's why, so you get this. Okay, this one. So let's see the mechanism of this reaction. Mechanism of this reactions are, first is the generation of electrophile. You must have the electrophile. How the electrophiles are produced? Now we have nitric acid and sulfuric acid. You know that a sulfuric acid is a stronger acid than nitric acid, because oxidation state of sulfur is a +6, while the oxidation state of what, nitric acid, that is nitrogen nitric acid, is +5. So here the proton is donated from nitric acid to sulfuric acid. So there is the concept of Bronsted acid and Bronsted base. Okay, so nitric acid loses the proton, so it becomes a what, acid, while sulfuric acid is act as a base. Now it abstracts the proton. Okay, so the concept is somewhat have here. First you listen what is the mechanism is that. Okay, in this reaction sulfuric acid loses the proton because it is a more acidic one. Nitric acid abstracts the proton, so it is a base. So formation of what hydronium ion, and that water is replaced, from that you get the NO2. So NO2 plus is nothing but the nitronium ion. This is the electrophile, and electrophile is nothing but the what? Electron deficient species. And we have already benzene is there. Now second step is attack of one of the pi electron on the electrophile, that is on the nitrogen, and there is a formation of what? The positive center complex, that is an sigma complex. So this is the mechanism of second step, where the one of the pi electron of benzene attack on the nitrogen. So the bond will be open to oxygen, and formation of what? A positive center nucleus. That nucleus, which is second step in second compound, in the second step, that is called sigma complex or aranium ion or Wilhelm intermediate. Why it is called aranium ion? Because there is a positive charge is developed on the aromatic skeleton, so it is called aranium ion. And last step is deprotonation. Okay, you get the three structures particularly for this positive charge. Okay, and after that you get the resonance hybrid. In the last step, I mentioned that the removal of proton by base. Now in base is that what is your base now? The HSO4 negative, which is first, in first step it loses the proton, so negative part is there, that negative part is available for the abstraction of proton, and uh, that finally loses the proton, and you get this one. So I sorry for that, last step is not mentioned here, but in second step already we are mentioning what the third step. So in this way you get a stable product, that is what the nitrobenzene. So now nitration is an example of what? Aromatic electrophilic substitution reaction. And always aromatic electrophilic substitution reactions are done in three steps. First step is generation of electrophile. We have second step is attack of pi electron from benzene to the electrophile, and third step, that removal of proton by base, you get the stable product. And this is the structure of what nitro group, where the electron density is maximum on oxygen while the minimum on the nitrogen. That's why your benzene pi electrons are only reacted with the nitrogen. What are the reactions of nitro compounds? And aromatic nitro compounds or aliphatic nitro compounds, they undergo the some similar reaction, because that NO2 is an oxidized form. Okay, so because they have maximum number of oxygen, so we can reduce easily. Okay, and to get the another compound, that is an aniline, etc. So first of all, reduction, catalytic reduction. So what exactly that reduction? Now reduction nothing but the what? We are just adding the more number of hydrogen with the help of what? Hydrogen source. Another example is that we are adding a number of electrons. This is another kind of oxidation or removal of oxygen. Okay, these are the some definitions particularly for what the reduction. In reduction particularly, we are one more commonly used is a catalytic reduction. What is catalytic now? A catalytic reduction is nothing but the reduction, okay, in a presence of what? Catalyst. And catalysts are nothing but the what? We are particularly from D series or D block series. We have palladium in presence of what? Carbon. Carbon is a support, okay, and in ethanol. So hydrogenation is the process. Now what is hydrogen? Addition of hydrogen gas over the unsaturated or over the pi bonded molecules, that is an NO2. Now for this, in this process we are converting that nitro group into what? The NH2, that is we are removing oxygen and we are adding what? The hydrogen. So this process is done in the presence of what? Hydrogen gas and palladium as a catalyst. So that's why this type of reaction or this type of what? Addition reaction is called catalytic hydrogenation. What is the role of carbon here? Carbon provide the support, carbon provide the support toward the catalyst. So in this way we are converting that nitro group into what? The NH2, and nitrobenzene becomes converts to aniline. So there are so many questions are simply asked, how can we convert that nitro compound into what? The aniline. We are using simple what? Catalytic reduction. In particularly there are so many different catalysts are there. SnHCl, that is tin in hydrochloric acid. Iron in HCl, we can use the iron also for the same process. We sometimes we are using zinc also, and sometimes we are have the palladium in carbon. Okay, so palladium carbon H2PDC. So this is the first most important type of chemical reactions of nitro compound is reduction. So by reduction of or after the reduction of nitro compound, you will get the aniline. Okay, now that aniline is a versatile molecule. From that we can convert so many different compounds, that is disodium salt. Okay, so etc etc, carbylamine, and we have lots of other acetanilide, etc. Next one, reduction in acidic medium. So what will happen when that NO2 group is treated with what, the acid? So just I am treated that Fe, Sn, zinc, but in HCl. Again that will be converts to what, NH2. So it is another type of a reduction, but reduction in acidic medium. So nitro compound is converts to first of all in SnHCl or metal in acid. Now you know that it becomes a what, aniline. First step is aniline, but in due to the acidic medium, aniline is a lone pair containing molecule having the basic character, so it will takes the proton from what, Ac, and that's why the first product is aniline hydrochloride, anilinium hydrochloride, and after that by the application of base the proton will be free, proton will be abstracted, and you get the aniline is a final product. So this is the second type of a chemical reaction, that is reduction in acidic medium. Nitro compounds in presence of what, SnHCl, ZnHCl, FeHCl. You can use anything, but metal should be there. Now third one, reduction in neutral medium. So for neutral medium we are using what, is zinc as a metal, and in ammonium chloride, that is ammonium NH4Cl. So nitro compounds in a presence of what, hydrogen. So we are converting that to again, but the product of this reaction is an hydroxylamine, that is the NHOH. Okay, so this is the product which is obtained. We are not getting this NH2. Okay, so that's why this is the different in neutral medium reaction. So that produces 40 hydroxylamine. We have also the nitro compounds ZnHCl, ZnNH4Cl, that is ammonium chloride, zinc in ammonium chloride in presence of and hydrolysis results in formation of what, hydroxylamine, phenyl hydroxylamine. Lastly, we have another type of a reduction, that is reduction in a presence of what, aluminum hydride. I just before said that reduction is done with the help of hydrogen source. Hydrogen source are coming from either from hydrogen gas, that is catalytic hydrogenation, or from particularly the what, aluminum hydride, that is a metal complex hydride. Okay, MH containing M means metal and hydrogen, metal hydride. So LiH or LiAlH4 is an example of what, the is an example of the metal hydride complex. It have the ability to gives hydride ion, that is H negative ion, not H plus. Okay, so before you keep in mind, LiH is one of the strong reducing agent. Okay, it gives the H negative ion, and always any nitro compounds are directly converts into what, the amine. So aliphatic nitro compounds are just reduced to what, the primary amine in presence of LH, and similarly we have nitro compounds are also be converts into. Now aromatic nitro compounds on reduction, they get converts into aniline as well as azo compound depending upon the type of equivalent are used of nitro compound. If you use the one equivalent, the product is what, aniline. If you use the two equivalent, the product is azobenzene. What is azobenzene? C6H5 N double bond N C6H5. That N double bond N is represent the azo group. Azo is nothing but the dye. So we have seen that there are so many compounds are present where have a bright color, that is an example of dye, and responsible for the dye or that color is an N double bond N group. So by the application of that LH on two equivalent of what, nitrobenzene, that will form the azobenzene. If one equivalent of nitrobenzene is given, then resulting product should be what, aniline. Reduction in basic medium, so it form different products depending upon type of reagent. So there are another is common is there. So zinc in NaOH, it will be directly converts to azobenzene, uh, or we have another nitro group in presence of what, arsenic oxide As2O3 in NaOH, that will converts to what, azoxybenzene. Azoxybenzene and azobenzene both are what, quite different. So these are the some familiar reactions particularly from dinitrophenol. Now what is selective reduction? If two nitro groups are present on the aromatic skeleton, okay, so if the reaction is asked, now how can you prepare meta dinitrobenzene, that is nitrobenzene which are in a 1,3 relationship to the benzene ring. Okay, if you have benzene ring and the two nitro groups are in a 1,3 relationship, that is called meta dinitrobenzene. So nitrobenzene undergo the nitration, not benzene, nitrobenzene, that is C6H5NO2 undergo the nitration, so that incoming nitro group will be directly attached with the meta position to the first one. So basically that type of compound is called what? The meta-dinitrobenzene. And one of the famous reaction or famous reagent that is called ammonium sulfide. Ammonium sulfide or sodium polysulfide is one of the best reagent to convert one of the nitro group to the what? NH2. And now here look at that, this is called selectivity. And selectivity is nothing but that your incoming reagent, that is ammonium sulfide, is probably is reacted with one of the nitro group, not both. If you use the FeHCl, ZnHCl or catalytic hydrogenation, both nitro group will be reduced to what? Aniline or NH2. But here ammonium sulfide is a selective reagent without affecting to the what? Double bond of benzene, or without affecting to what? The one of the nitro group. So one nitro group and benzene ring becomes intact as it is. While doing this reactions, only one NO2 group will be converted to what? The NH2. So this is the beauty of what? Selective reduction. Okay, you must know that reagent, that is ammonium sulfide. Okay, or you must remember this reagent because it selectively reduces one of the nitro group. It's not a it's one of the big deal. So reactive removal of nitro group. Now another beauty, look at this one. So we can convert that benzene to nitrobenzene or nitrobenzene to benzene. So there are so many type of transformations are there, and that type of transformation are called functional group transformation. So nitro group can be substituted or nitro group can be removed. There are two quite different reactions. Benzene to nitrobenzene can be done with the help of nitration, while nitrobenzene to benzene can be done with the help of some multi-step reaction. So now we will see that. So now this is the beauty of these reactions, where first of all that nitrobenzene is an oxidized form, that NO2 first convert into what? NH2, that in presence of what? Metallic acid, that is SnHCl, FeHCl. That NH2 will be converts to diazonium salt. You have the chapter that is called diazotization or diazonium salt. NH2 will be converts to into N2, that is azo group or diazo group. Di means 2 and azo means N2. So after the diazotization, that you get the compound is diazonium salt, benzene diazonium salt, and by the application of what? H3PO2. Okay, it is an acid in presence of copper chloride. It directly remove that diazonium group into what? The benzene. So look at this reaction. It is called multi-step synthesis, conversion of nitrobenzene to benzene, or we are removing that NO2 group. What are the steps are there? Nitro group first converts to NH2 with the help of what? Catalytic hydrogenation or with the help of what? Metallic acid. That NH2 which converts into what? The N2 plus Cl negative ion, that is diazotization in the presence of what? Sodium nitrite and hydrochloric acid, NaNO2 or HCl, or sometime HNO2 is also given. And lastly that diazonium group is removed with the help of what? The H3PO4 is an acid, and H3PO2, and finally so results in again in combination with copper chloride, and finally gives the benzene. So in this way you can remove that NO2 group. Another familiar chemical reaction of what? Nitro compounds is an electrophilic substitution reaction. This nitro group is strongly deactivate the benzene. I just say that benzene is an electron rich compound. Why? Because of there is a continuous pi cloud is present, pi bonds are present. That's why benzene are electron rich. But due to the nitro groups are attached to that benzene shows the what? The deficiency. Why? Because of NO2 group have the tendency to withdraw the electron. Now just imagine, just recall to that resonating structures of what? Nitrobenzene. So nitrobenzene is which nitro group deactivates to benzene, that is withdraw the electron from the benzene particularly. So benzene becomes a deficient, and if you see the resonating structures of what? Nitrobenzene, so we see that there are the positive charges are developed on the what? Ortho and para position, and that's why benzene is deficient, so require the strong conditions. Firstly we are looked at nitrobenzene or this aromatic nitro compounds treated with this HNO3 H2SO4, that is nitrogen mixture at 383 Kelvin results in the formation of meta-dinitrobenzene. How this transformation are produced now? So first step is, it is an example of aromatic electrophilic substitution reaction. HNO3 and H2SO4 are combined together. HNO3 H2SO4 combined together converts to what? Nitronium ion. that nitronium ion is only substituted at meta position. Why? Because of nitro group from nitrobenzene withdraw the electron from ortho and para. That's why ortho para deficient position than what the meta. So incoming NO2 group, okay, which directly substituted at what the meta position. Okay, you must go through the resonating structures of nitrobenzene, then you will get the concept. Okay, and in this way this electrophilic substitution is only done on the meta position, and but for this process we require a strong condition, because benzene here is a less deficient. Okay, benzene is a deficient center here. Now nucleophilic substitution reaction can be done because nitro group is a withdraw the electron density from benzene, so benzene becomes a deficient. So any nucleophile can be approached, and that react with the leaving group, and leaving group will be displaced. Nucleophilic aromatic substitution is in bimolecular displacement, that is in two step or two molecules should be required. So what are the example is here? So we have what aromatic skeleton, it must be NO2 should be there, and at the same time your leaving group is there, that is in X. So the chemistry of this reaction is the leaving group should be, or the withdrawing group and leaving group, they must be ortho or para to each other. Okay, aromatic ring must contain strongly withdrawing group as like NO2, and they should be ortho and or para to the what leaving group. Okay, we have had the skeleton is there. So nitro group facilitate the nucleophilic substitution reaction by stabilizing the intermediate carbanion as depicted below. So this is an example where chloro 2 para chloronitrobenzene, where chlorine and NO2 are para to each other. Incoming OH negative ion are directly come toward the carbon where Cl is attached, and in first step, okay, electron densities particularly in first step we are just adding the nucleophile, we get the carbanion as intermediate because your electron density is reached because of the OH, and finally displacement of Cl, we get the product. So the synthesis of paranitrophenol is only with the help of an OH negative ion, that is an hydroxide ion. So what is the mechanism of this reaction? So NO2 is one of the best withdrawal as earlier said, because have the maximum number of electronegative element, that is oxygen, 2 oxygen and 1 nitrogen. So that mechanism is also be called SNAR, or that mechanism is also be called addition elimination mechanism. Okay, so it is a part of what aromatic nucleophilic substitution reaction, not electrophilic. Okay, because we are substituting what the nucleophile. This mechanism is proceed in the two step. One is addition of nucleophile. The first step is addition of nucleophile to form a carbanion as earlier said, because electron density is reached. Okay, then now this is the mechanism here. W considered as our NO2 and Cl is the leaving group. So nucleophile is first added, form the negative charge, that is a carbanion, which is stabilized by W. That's why W should be there, that's why withdrawing group is there, and finally you get carbanion center. And second step is we have what, departure of leaving group, that is in second step. So the leaving group will be departed, so loss of leaving group to reform the aromatic ring, because aromatic ring should be stabilized, and in this way this negative charge is shifted, and that Cl or the leaving group will be free. So in this way, so this mechanism, that is a nucleophilic substitution reactions, are proceed in two step: addition and elimination, addition of nucleophile, elimination of the leaving group. So this is the mechanism particularly. Now among the following compounds which undergoes the what, faster nucleophilic substitution reaction, these are the three compounds are given. This is orthochloronitrobenzene, then 2 4, then we have another example B, that is an disubstitute dinitro compound, and third is what, the fluorine. Okay, you know that what is the reason behind that, which halogen get displaced first. So as you know that nucleophilic substitution is enhances with the help of increasing electron withdrawing group. With more number of electron withdrawing group, so the reactivity will be increases. And secondly, electronegativity of the halogen. Now more the electronegative halogen withdraw the maximum electron, stabilize the carbanion. That's why, so there are two factors are there. Okay, this one. So this is the increasing reactivity from A to B, B to C, because in C, so more electronegative elements halogen is there, and secondly we have more number of nitro groups also there. There are two factors are there for that. One is a increasing number of electron withdrawing group increases the reactivity of aryl halide, that is electron withdrawing group is there maximum, it can stabilize the carbanion, I just mentioned in the mechanism. And increasing the electronegativity of halogen, that is from fluorine, chlorine, etc., etc. You know that fluorine is most electronegative than other halogen, so that increases the reactivity of aryl halides. As more electronegative halogen is present, so it stabilizes the intermediate. Okay, and that's why ARF. So in generally carbon fluorine bonds are quite stronger, but in this case carbon fluorine bonds are what, weaker bond. Why? Because of the fluorine have the tendency to withdraw because it is more electronegative. So this is the reason behind that. So you must see that some versatile reactions where in other cases we are called that ARF, that is a CF bond is more stable because carbon fluorine belong to both the same period 2p 2p, and if same symmetry is there, orbital symmetry, then it's difficult to break the bond. But in this case, so the mechanism is different. So you must know this type of what example, you must go through this type of the examples. Okay, let's move to the self quarantine questions. Okay, we are not we must go through this example, and with the help of your own mind, with the help of your own, everything is own. That's why I had just mentioned that self quarantine question. Draw the product of each reactions. We have product, we have reactants are there, so, side by side we also given the reagent. This is an example, first example, find out the product and you must send me or the text me in the comment box. This is second answer. Find out the nucleophile, find out the electrophile. What we have to do now? Third one, this is this example, hydroxide as a nucleophile, and lastly fourth one, this one. Now look at this four example. In all the four example here, halogen, and that is halogens are leaving group, and secondly what, all are the what, the electron withdrawing groups, they are always present ortho or para to that leaving group. What is leaving group now? Why halogens are best leaving group? Because after removing from that, F becomes converts to F negative, Cl becomes a Cl negative, Br becomes a Br negative, and now that halides becomes a converts to what, that halogens becomes a converts to what, a halides. What is halides? Now X negative ion, and X negative is in full of octet, that's why it is a stable. So leaving group are nothing but the group which is stabilized after the departure. Okay, from after leave from that molecule, it must be stabilized, that's why it's called the leaving group. Acidic nature of what, alpha hydrogen, another most important characteristic, but it is only related to aliphatic, it is not an example of what aromatic nitro compound, because in aromatic nitro, that nitro group is directly attached with the sp2 hybridized system, while in aliphatic system nitro group is attached with the sp3. So if you consider the alkene, so alpha hydrogen, because again just we have one chapter, that we have one point, that is active methylene group or reactive methylene. What is reactive methylene? When CH2 is directly linked with any electron withdrawing group. Consider that NO2. Here NO2 is when attached with that CH2 group, that is methylene. So that CH2 shows the deficiency, and that CH2 is, so what is alpha now? Alpha means adjacent to nitro group, that carbon is called the alpha carbon. What is alpha carbon? A alpha carbon is nothing but the, it will directly attach with the what, nitro group, and that hydrogen on the CH2, that are called the alpha hydrogen. Now that alpha hydrogens are show the deficiency, they show the acidic character, and that's why it is just due to the NO2 group. So it give rise to an aldol type of reaction. Okay, you know that when two carbonyl compounds are mixed together, you get the beta hydroxy compound, beta hydroxy carbonyl, that is called what, the this aldol. And similarly, what is an nitroaldol reaction? One famous reaction is given, that is called which is given by what, Henry, which is only in aliphatic nitro compounds. Okay, I just again tell with that it is an example of what, aliphatic. Now this reactions particularly which is have this mechanism, so nitro compounds are reacted with, the nitro compound should have the alpha hydrogen, that must have the what, CH3 group, CH2 group. Okay, so or CH group. So look at this reactant. First, nitro group is in deficient withdrawing group, it withdraw the electron, that's why the hydrogens adjacent to that are more acidic. Base abstract the proton, base is what, abstract the proton, base abstract the proton and makes the negative charge, that is carbanion. So carbanion is stabilized by what, nitro group, and then that carbon ion is reacted with the what, carbonyl carbon of what, nitrogen, so it is second equivalent, and you form what, the hydroxy derivative, and finally removal of water, which leads to what, the your product, that is what, alpha beta unsaturated nitro compound. Now this type of reaction is quite similar to that of aldol. That's why it is an reaction is called what, the Henry aldol. In Henry aldol we are using two equivalent of what, compound. One is a nitroalkane and second is what, the carbonyl carbon. Okay, here nitroalkane is a source of nucleophile, and while your carbonyl compound is a source of what, electrophile, and we are combined together in presence of base, you get the conjugated one. So this is the mechanism I just refer. Particularly this is an animation example, you must gone through that. So look at this one. So first of all base is come. Okay, base is, because that, now here look at the CH now. So I will again show you the same mechanism. This one, a base abstract, that is base is nothing but different, sodium hydroxide, potassium hydroxide. So that CH is an acidic, because due to the NO2, that base comes, yes, like this. Okay, so the base is abstract the proton, generate the negative charge like this one. So this is the application of just a base. Now that negative charge is delocalized. Okay, what is delocalization? The negative charge should be always present on more electronegative element, here previously in carbon, and now it is on oxygen. So that's why, and now that negative charge on the carbon is reacts with what, the second equivalent, that is in carbonyl carbon. Look this. So that carbon negative charge from the nitroalkane is reacts with the carbonyl carbon. It is an example of nucleophilic addition, and after that protons are available here. Protons are donated by the proton source. So finally you get this one. So that compound is called what, beta hydroxy nitro compound. Beta hydroxy nitro compound. It is an example of carbon carbon bond formation reaction. And after the what, removal of water, after the what, removal of water, you get the condensed product. What is condensation process? Removal of water. Removal of water, from that you get the alpha beta unsaturated carbonyl, alpha beta unsaturated nitro compound. And lastly, so we must know the applications of what, nitro group. Generally nitro groups are a compounds were used in the explosive. Okay, so nitro group is a major importance in industry, particularly include nitrobenzene, mononitro or dinitrotoluenes, trinitrotoluene, TNT. Okay, so where the nitro groups are shifted at the 2, 4 and 6 position. Okay, 2, 4, 6 trinitrotoluene is one of the explosive. Then we have what, picric acid, another example. As I already mentioned in the figure, picric acid is synthesized by what, the just substitute the Cl at that OH position, and incoming OH is the nucleophilic substitution reaction. Mononitrobenzene, nitroanilines, nitrochlorotoluene, nitronaphthalene, dinitronaphenol, picric acid, and what, the dinitrocresol. All are the compounds were used in the what, the industry. They have lots of application in industry particularly. Aromatic compounds are have the few direct uses other than what, formulation of explosive or the solvent. Sometimes the solvent in organic chemistry or explosive. In the leather industry, metanitrophenol is a fungicide and paranitrophenol is a chemical intermediate for what, the leather preservative. Okay, 2,4-dinitrophenol is useful as a manufacturer of photographic developers and serve as a wood preservative and insecticide. So, and lastly, 2-nitro paraphenyl diamine 4 amino 2-nitrophenol is a component particularly used in the what, the permanent hair dye products or fur dye, etc., etc. So because we have the already topic is nitro compound, and so you must know the what are the applications of a nitro compound, etc. That's why I am taking this slide. So these are the uses of nitro compounds. Here I mentioned the two compound, one is picric acid and second is called the tetryl. So these are the some applications of a nitro compound, and thank you for watching this lecture particularly, this is a strictly on based on the what syllabus of a BSc second year semester 4, and section is organic chemistry. If you really like or this happy with the contents, you must subscribe and share with the other your colleagues. Thank you for watching.